So starting with lesson 5, which is on simple interest, the key idea is to, keep in mind is that simple interest is found by multiplying principal, rate, and time. So here's the formula: I equals PRT. The time must be written in terms of years, write months as a fraction of a year. And then to find the amount paid back, all you need to do is add the principal and the interest. Interest is a fee that's paid for the use of someone else's money. So if you put money in a savings account, you would receive interest from the bank. But if you borrowed money, you would be paying interest. In either case or in either scenario, the amount that you invest or borrow is called the principal. So simple interest is a percentage of the principal multiplied by the length of the loan. The formula for finding simple interest is given on the sheets of the mathematical reasoning test. The version of my book was really small to see, so I did find the formula sheet on GED.com. But it looks like a 2014 version, but just be aware that there is a formula sheet that will be available to you during the exam. And if you look on the formula sheet and you see formulas that you don't, that you use that are not present on the sheet, just go ahead and memorize them, but make sure that you, or just be aware rather that there'll be a formula sheet available to you during the test. So the simple interest formula, as we saw earlier, is written as interest equals principal times the rate times time. So you may find it easier to remember the formula using variables. So I equals PRT, where I represents interest, P represents the principal, R is the rate, and then T is time. And obviously, as we saw, I think it was in chapter 1, there are different ways of representing multiplication. And in this particular instance, where we see PRT written together, that's an indication that these variables are being multiplied together. So in this example, we're being told that Asher borrows $2,500 from his uncle for 3 years at a 6% simple interest rate. How much interest will he pay on the loan? And as we've seen from the last lecture, we can rewrite 6% as 0.06 by dropping the percentage sign and moving our decimal point 2 places over to the left. And so we rewrite 6% as 0.06. And then you want to substitute the known values into the formula and then multiply as the formula prescribes. So we know that interest equals the principal times the rate times the time. In this particular example, the principal is $2,500, or the amount that Asher borrowed from his uncle. The rate is a simple interest rate at 6%, which we've already changed to our decimal 0.06, and then you multiply that by the time, and in this example, that's 3 years, and we find that our answer is $450. So in addition to the principal that Asher has to pay back to his uncle, he's also paying interest in the amount of $450. So some problems may ask you to find the amount paid back. And in that instance, the additional step would just require you adding the interest that you found to the principal. So in our example with Asher, to find the amount that he needs to pay his uncle back, you would add the principal amount that he borrowed, which was 2,500, to the interest that we just found, which is 450. And you would find that the amount he has to pay his uncle back is $2,950. So, as I mentioned earlier, an on-screen formula sheet will be provided to you when you take the mathematical reasoning test. The formula for simple interest is printed close to the bottom of that sheet. So every time you see a formula in the book, check to see if it's on the formula sheet, as I mentioned. And if the formula is not there, you'll need to memorize it. Excuse me. So this is the formula sheet that I did find online. Might be a little bit hard to read, but closer to the bottom, you'll see the simple interest formula right there. And I got this from GED.com. In a simple interest problem, the rate is always an annual or a yearly rate. So the time must also be expressed in years. So in this particular example, we're told that Eva invests $3,000 for 9 months. She will be paid 8% simple interest on her investment. How much interest will she earn? Well, again, we want to start by writing our simple interest rate in decimal form. We're going to drop the percentage symbol and move our decimal point 2 places over to the left. And we have to remember, because the rate is annual, since the rate is annual, we have to reflect our time, or we have to express our time in years as well. So we're going to go ahead and change 9 months, or represent 9 months in terms of years. And to do that, we'll simply just divide 9 by the total number of months in a year, which is 12. And so 9 over 12 simplified will be 3/4 of a year. And so now we can go ahead and find our interest by just multiplying the principal, $3,000, by the rate, 0.08, and the time, which is our fraction here, 3/4, or 0.75. So you can either use your fraction key on your calculator and enter 3/4, or you can just simply convert 3/4 to its decimal equivalent, which is 0.75. And then we find that Eva will earn $180 in interest. So your practice questions on simple interest beginning on page 721 to page 724. So in terms of percent of change, there are several key ideas that you need to keep in mind. The amount of change is the difference between the new number and the original number. So you want to find the percent of change, you simply divide the amount of change by the original number. And then the percent of just keep in mind that the percent of increase in some instances may be greater than 100%. So percentage is often used to show change. And in this particular example, we're told that Michelle recently started her own business. Last month, she earned $1,000, and this month she earned $2,000. How should she describe the interest in her earnings? Well, all the following statements accurately describe the change in Michelle's income. So Michelle's earnings doubled from last month to this month, and we know that because 2,000 is $1,000 multiplied by 2, essentially double her interest. Double her income. This month, her earnings increased by 100%. So we can visualize or reimagine this $1,000 income as one whole, right? So $1,000, made this little visual representation of what's being described here so that you can maybe have a better understanding of what is being discussed. So $1,000 is the equivalent of one whole. So if we want to find out the percentage increase of her earnings, we would just simply multiply one by the percentage of increase. And in this particular case, it's 100 because her entire income increased by the same amount. It didn't increase by a portion, like it didn't increase by 10%, for example, which would be $100 in this case, nor did it increase by $200, which would be 20% of 1,000, right? It increased by $1,000, which is exactly 100%. And so you would multiply one or the equivalent of her whole income by the percentage increase, which is 100%. And as we discussed earlier, percent simply means over 100, right? And so we know that her income increased in its entirety, right? It wasn't a portion, like if it was 10%, we would see 10 over 100 here. But since her income increased in its entirety, her income increased by 100%. And that is essentially what is reflected here and what the statement is trying to let us know. We also can deduce from the information that we've been given that this month's earnings are 200% of last month's earnings. And again, if we wanted to find out the equivalent of her income increase, all we have to do is look at the new amount, which is $2,000. And since we've already predetermined that 1,000 is the equivalent of one whole, remember our lesson on ratios. If 1,000 is to 1, then 2,000 is to 2. We can redefine 2,000 in the sense of its whole as 2, and then you simply multiply 2 by the percentage. And again, the amount increased in its entirety. It wasn't 10%, it wasn't 20%, it was 100%. And so you simply multiply 2 by 100%. And that would give you 200 over 100. And then rewriting 200 over 100, you can rewrite it simply as 200%. And again, I used color coding here to help with understanding. So multiplying across 2, we could rewrite as 2 over 1, right? And so 2 times 100 is 200. 1, which would be the denominator of 2, this whole number, times 100 is 100. Okay, so 200 is the amount of increase, and then we know that it's a percentage, so 200 over 100 equals 200%, or 200 over 100 can be rewritten or represented as 200% mathematically. So percent of change compares a new number, which shows an increase or decrease, to the original number, the number before the change. So in this particular example, we're told that Lisa earned $10.50 per hour, and now she earns $11.34 per hour. And we're being asked to find the percentage, the percent raise that her boss gave her. What percent raise did her boss give her? So we simply start by subtracting the amount of change, which would be her new amount, which is $11.34, minus what she used to earn, which was $10.50. And so we now know that the amount of change is 84 cents. And then you would divide the amount of change by her original amount that she was earning before the change. And so you would simply divide 0.84 by $10.50. And you would find that your answer is 0.08. And then to change this decimal to its percentage equivalent, you would simply multiply by 100%. And that would simply involve you moving this decimal place twice over to the right to indicate that you've multiplied 8 by 100, rewritten in its percentage form as 8%. So you can work backwards to check your answers. For example, if the price of an item decreased by 25%, the new price should be 75% of the original price, since 25 plus 75, 25%, I should say, plus 75% equals 100%. So you think carefully about a situation in order to determine, or in order to decide which number is the original amount. So in this example, we're told that a jacket is on sale for $90. 3 days ago, the jacket went on sale for $120. By what percent was the price of the jacket reduced? Well, you simply subtract to find the amount of change. So 120 minus 90 equals 30. And then you take the price that the jacket was before it was reduced to 90. So 120 is the original price, or the price of the jacket was $120 before it was reduced to 90. So 120 is the original price. And then you want to divide the amount of change by 120. So the new price is 25%, 30 divided by 120. If you wanted to do this just kind of quickly in your head, 0 and 0 would cancel each other out. 3 goes into 3 one time, 3 goes into 12 4 times, and we know that 1/4 from our previous lesson is the fractional equivalent of 0.25. So you want to change 0.25 to percentage form by simply multiplying 0.25 by 100%. So 0.25 times 100, we're moving the decimal place over to the right 2 times. That would give us 25 over 100, which we represent as 25%. So percent of increase can be greater than 100%. For example, Calvin started his business with 10 employees, and now he has 60 employees, and we're being asked to find by what percentage his workforce increased. Well, we would start by subtracting to find the amount of change. So the new number of employees that he has is 60. He initially started with 10, so 60 minus 10 is 50. And then you divide the amount of change by the original number. So in this case, the amount of change is 50. The original number that he started with, the original number of employees is 10. So 50 divided by 10 is 5. And we change 5 to its percentage equivalent by multiplying by 100%. So 50 divided by 10, the zeros cancel each other out. 5/1 is the same as 5. 5 multiplied by 100% means that we're moving our decimal place 2 places over to the right to reflect that we're multiplying by 100. So 500 over 100 can be reflected in decimal form as 500%. Practice exercises on page 725 to 740. And so this chapter, well, basically lessons 1 to 4 we covered on Tuesday. So to review that, you can simply just re-watch the video. But I did want to mention long division on 2 particular examples appear a little bit confusing. So I do want to go over those really quickly. It's not that, let's see. Okay, so here's one. This was an example on solving for the base concerning the percentage formula. So in this example, we're told that the workforce at Eastland Inc. is growing rapidly and the number of employees this year is 225% of the number last year. If there are 135 employees this year, how many employees did the company have last year? Well, so we know that the base number, or the base is the number of employees that the company had last year. And this year's number is a percentage of last year's number. So the rate, which is 225%, is a part of 135, right? So the base is what we don't know, right? We're not giving it any information about the base. We know information about the part, and we know information about the part, and we know information about the rate, which is 225%. So you cover the base in your pictogram that represents the percent formula. So we know that we're to find the base, we're gonna need to divide the part, which is 135, by the rate, which is 225%. So start by rewriting 225% in decimal form. You drop the percentage sign and move the decimal point 2 places over to the left. And then you go ahead and divide 2.25 by 135. So write out your long division, 2.25 divided by 135. Now, you're gonna move your decimal point 2 places over to the right, so that 2.25 becomes a whole number. And so because you moved exactly 2 places over to the right in your divisor, we're gonna move exactly 2 places over to the right in the dividend, okay? So that those numbers remain equivalent. So I covered, I thought it was a little bit confusing that the directional arrow started here in the book. So I covered that to reflect where the decimal point actually is, right? Which is right after the last digit, 135. So you move exactly 2 places over to the right. And so this is where you would put your decimal point before you start dividing. And so now we're dividing 225 by 13,500, right? So we essentially ask ourselves, the questions that we normally do when we start with our long division. How many times does 225 go into 1? Well, it doesn't, right? Because 225 is greater than 1, so we skip over to the next place. How many times does 225 go into 13? It doesn't. Skip over to the next place value. How many times does 225 go into 135? It doesn't. So we skip over to the next place value. which is the thousands place, how many times does 225 go into 1,350? The answer is 6. 225 times 6 is 1,350. Subtracting that, we have 0, but we're not done because we have one more digit to bring down. In this case, it's 0. So 225 into 0 is 0. And so you write down 0 to reflect that. Now we're done with our long division, and we see that our decimal point is where it should be. So you would write down your answer as 60 employees, okay? I think the other example that I wanted to, yeah, it's this one right here. This is also another instance of solving for the base. So in a math class, 75% of the students got at least a B grade on the final exam. So if 18 students got at least a B, how many students are in the class? So the 18 students are part of a larger class. You know that 18 students are 75% of the whole group. So 75% is the rate. The base is unknown, and we know the part is 18. And so you simply want to convert 75% to its decimal equivalent, which is 0.75. And then you would divide 0.75 by 18. And so again, you want to move your decimal point 2 places over to the right so that 0.75 now becomes a whole number, 75. And you would do exactly the same thing with 18, move only 2 decimal places to the right. And so if it's easier for you, you can rewrite this so that you're not worried about the decimal points in the divisor and the dividend. You can rewrite this as 75 divided by 1800, but we know that our decimal point is going to go right here, right above the last digit in our dividend, which is the 0 right here. So our decimal point is going to go right there. And then we just continue with our long division as normal. How many times does 75 go into 1? It doesn't, so we move over to the next place value. How many times does 75 go into 18? It does not, so we move over to the hundredths place. How many 5 does 75 go into 180? The answer is 2. 75 times 2 is 150. And so we subtract 180 minus 150 is 30, but we're not done. We bring down the 0. 75 into 300 goes 4 times. 75 times 4 is 300. 300 minus 300 is 0. So we know we're done with our long division. We don't have any remainders, and our decimal point is exactly where it should be. So we, in this example, it's reflecting a whole number of 24. So we know that there are 24 students in the class, which is our base. Okay. So that's pretty much it for today's lesson. Do go over or do rewatch the video on lessons 1 to 4, and then the video for today's lecture as well, which covers lessons 5 and 6.